All right, so this first one, all we have is f of x equals 2. There's not even a variable. Does anyone remember what that's called? If not, I'm going to tell you, but I'm just throwing the question out there to see. Do you remember what that's called? It is a type of linear. So it will be a line. It's like a special kind of line. Because linear is always what everyone says first. All right, so it is constant. Constant means unchanging. So if there's not a variable, it's not changing. It's just going to be a horizontal line wherever the number says it is. So this one I wrote 2, so it's just going to be a flat line at 2. A constant function could be f of x equals 7 or f of x equals -3. It just doesn't have an x in it. It doesn't have a variable. So it's like the most boring graphs ever. All right, this one is linear because there's at least a variable. It's almost more confusing when there's nothing there. When it's the parent function, like it hasn't been changed at all. And don't worry, we're going to change them and do all. Do you remember all the transformations? We're going to do all those next time. But what's really in front of the x if there's nothing there? 1. Okay, so the slope is 1. You're going to start at the origin and then do a slope of 1, up 1 over 1. Do you remember back in algebra 1 where like a month of your life was slope? Like up 3 over 7, down 2, left 5, you know. This one's just 1. But we're just doing the parent functions right now. We're not changing them at all. So they're still all just like centered at 0. All right, how about 3? What is that one going to be called? Absolute value? And does anyone remember what kind of like shape that one is? The V shape. So it's centered at 0, 0. That's like the center of the V shape. And then it still goes up 1 over 1 in each direction. It's essentially the linear graph, but this piece down here gets reflected up there. And that's because an absolute value is always positive. It's a distance from 0, and distances can't be negative. So it still goes up 1 over 1. It's still a slope of 1. It's just the negative part is now positive. Some algebra 2 students like that come from algebra 2 say they've heard of this one before, and some say they haven't. So I have a feeling like some teachers cover it and some don't. It's like these bolded absolute value bars. Is that familiar to anyone at all? Like, or have you seen, like, okay, that's totally fine. It is called greatest integer. Greatest integer, but its nickname is the step function, and you'll see why when I show you what it looks like, because it looks like a staircase. But I really, and people end up hating this graph. They're like, that looks so weird, but it's actually really applicable. Here's an example. Do you know how at like Lowe's and Home Depot, you can rent a truck? Like if you needed to like haul some big things, do you know what I'm talking about? So there's like a flat rate for renting it, like you pay $50 and then you pay per hour that you have it. But if you have it for like an hour and a half, you know how they'll charge you for 2? Do you get what I'm saying? Like if you have it for any portion of an hour, they're going to round it up to the next hour. Or this is like a gazillion years ago, and you won't even like remember this. But back in the day, with your phone, your cell phone, they would charge you by the minute. And if you talked for like 5 minutes and 3 seconds, they would charge you for 6 minutes. Like they would bump you up to the next step. I know you're all just staring at me, but is this information going? Okay. So it ends up looking like a staircase. And those examples that I just gave are examples of how this is used. So it's still going to start at the origin. You're still going to put a point at the origin. And you're going to stay on that first step, like a flat line, until you get to 1. Put a little open circle there, and it jumps up to the next step. So that's where they jump up to the next amount. And so you end up with this infinite staircase, and you can draw like, I don't know, draw at least 3 steps of it is usually what I require, but it looks like this infinite staircase. But those examples I gave of how they charge for things is usually how it works. They'll jump you up to the next step if you have even a portion of a minute or a portion of an hour or whatever they're charging you by. But that's usually the one that's kind of brand new for everybody. I think it looks cool. A lot of people end up not liking it, but that's fine. Do you remember what this one is called with the squared?
Quadratic.
Quadratic. Beautiful. And do you remember what shape it is? Yeah. It's a U shape. We have a fancy name for what the U shape is. Kind of sounds like a disease. Parabola. So it's still centered at the origin. You can still put a point at 0, 0 because we're still doing all the parent functions. And then let's try and plug in some other numbers to get more points. If you plug in 1, what do you get? In other words, what is 1 squared? 1. So you get the point 1, 1. People usually get frightened in pre-calculus of what do I have to be able to do without a calculator? You just did it. 1 squared is 1. Good job. Now let's try plugging in 2. What is 2 squared? If you can do that kind of math without a calculator, you're going to be fine. When we plugged in 2, we got 4. So you can plot the point 2, 4. Now, because it's going to be symmetric, how can I get some more points without doing any more work? Yeah, like -1. Yeah, same place. -1, 1, it's like a buy one, get one deal with the points. So it's going to be this U shape. But yeah, don't be worried about what you have to be able to do without a calculator. If you can do basic math, like add, subtract, multiply, divide, like if you know your times tables, and if you can square some numbers and cube some numbers, then you're going to be just fine. All right, this one is square root. And so it's going to be like if you took the parabola and turned it on its side, except you don't get the whole thing. Why can't you have this as a graph? Like this should bother you. You should be like, something is wrong with it.
Square root can't be negative.
You can't square root, or like you can't get a negative result when you square root. And also, like, what is wrong with it, like graphically? Yeah, your vertical line test, it wouldn't be a function. So you're only going to get half of it. So it's going to be the parabola turned on its side, but you only end up with half. So again, still start at the origin. And then I would plug in 1. Hey kiddos, what's the square root of 1? 1. So you get 1, 1. Now you don't want to plug in 2 though. I don't know what the square root of 2 is off the top of my head. What's the next like pleasant number you could plug in? 4. If you plug in 4, square root of 4 is 2. So you get 4, 2. So it's going to look like this. But again, that's what you need to be able to do without a calculator. There's nothing to be scared of not having a calculator. If you can like do some basic math with little numbers, then you're fine. And I'm going to just get you there. I get everybody there every year. It's going to be just fine. We all hanging in there so far? Think we're good? Am I moving too slow? Can I pick up the pace? Are you all like, we got it? Or I don't know. I never know like where everybody, like what everyone's comfort level is coming in. All right. Do you remember what this one is called? The cubed. Yeah, cubic. I'm going to go ahead and write the next one as well. This one is cube root. Because they're inverses of each other, so it's going to be the same thing turned on its side like we just did. Do you remember what shape this is? Or like, did you have a word for it? Usually everyone kind of comes up with their own, like a wiggle thing. You know what I'm talking about? Squiggle. All right. So again, still centered at 0, 0. If you plug in 1, 1 cubed is 1. And then let's have this talk. 2 cubed, please no one say 6. Thank you. It's 2 times 2 times 2, which is 8. So you get 2, 8, which I think is actually like right on the edge of the graph. Yeah, it is. And then to save yourself some work, because I know it's going to be that wiggly shape, I can take those points and do the symmetric points on the other side. So do you see how I just took them and put them on the other side? You don't have to do any more work if you know the symmetry of the graph. It's not being lazy, it's being efficient. You want to be as efficient as possible. And so what you're going to do for this graph is you're going to take this one and turn it on its side. So you're still going to have 0, 0, and 1, 1, but instead of 2 8s, it's now 8, 2. And it's going to look something like this. And then usually here's where I get, how do I know the difference? Basically through practice, but the other thing I always say is the root one is sideways, like the roots of a tree is what I've heard before, is people use that to help them remember, like the roots of a tree grow out sideways, so that's the sideways one. Because I get one is upright and one is sideways, so I get that that's weird. But a lot of things are like that in math. One is one way and one is the other, and you kind of just have to remember it. I put 2 examples of this one on here. 9 and 10 are the same thing. Does anyone remember what this one's called? It begins with a P. Or we could play Hangman again. I like these because it's a pattern, and once you learn the pattern, then you're good. I just stuck 2 of them on there so that, like, usually when I do one, everyone's like, I kind of got it. And then when I do a second one, they're like, oh, okay, now I really get it. So that's why I do 2 of them. First thing you're going to do is put the zeros on there. So what would make this 0? Good, because 3 minus 3 is 0. So you can plot 3, 0. And then what would make the other factor 0? Yeah, so essentially it's just the opposite. So -4. The only thing that's kind of weird about them is you have to go right to left. Or your teacher may have taught it a different way. I think you just usually say go right to left. Do you see a negative out front? No, that means the right side goes up. And I'll just draw like a little arrow, like, oh, that's going to go up. And the only thing you have to do is make sure you look at the right number. So when you connect to the 3, look at the one with the 3 in it, okay? This is the one with the 3 in it. There's no power. What does that mean the power is? 1, and that means that you just cross straight through like a line. And when you connect to the -4, that's the one with the 4 in it, that one's squared. So what does that mean you do there? U-shape. I'll call it a bounce, but a U-shape like a parabola, like a quadratic. So when you get there, it bounces off and turns around. I love these because it's like doodling. They're just little doodles. But we'll try one more because, again, usually, and I know half of you are probably sitting there like this right now, like I kind of got it, but not really. So we'll just do another one. What are the 2 zeros we can put on there? Yeah, -4 and 5. Do you see a negative in front?
Yes.
Yes, that means the right side goes down. So I'll just put like a little arrow on the right side going down, and then just make sure you match them up right. When you get to the 5, you have to look at the one that has the 5 in it. That's this one. That's cubed. So you're going to do like a squiggly thing, like a cubic graph. Just make an attempt. I always get like, I can't draw that. Well, you know, if you drew this one, okay, it's the same exact thing. And then what are we going to do with the -4? Bounce. Yeah, U-shaped like a parabola. Cute little doodles. $11 and 12 are the same kind of thing too. Again, I put 2 just to have 2 examples. Does anyone remember what those are called? Ooh, rational. The root word of rational, not rat, it's ratio. Ratio is a fancy word for fraction. Something over something else, so rational. These ones, I'm not picky about what points you're going to plot. What's more important are those asymptotes, those invisible fences. So I'm going to use a different color, but you can do whatever you want. I'm just going to dot those in on the axes. I get that it's hard to see, and plus they're invisible. These are like everyone's least favorite graph. But do you remember how it looks like this? Like there's these 2 arms of it and they just kind of coast along. Does that ring any bells? It looks kind of like an hourglass. Okay, I'm seeing some heads nodding. I'll take it. And this one's going to be the same thing, but I stuck a squared in there. When you square a number, what does it do to it? Like any number squared is going to turn what? Positive. So both of the arms of the graph will have to be up here, what I call above sea level. So the squared just made it like both positive. How the absolute value graph took that negative part and turned it positive. You're doing great. We're almost done, guys. We got through like all the really difficult ones. So here the x is where? Exponent. So this is exponential. And I'm gonna go ahead and do these together. This one is logarithmic. They are inverses of each other. So when you do one, the other one, you just flip it on its side. I'm not going to get too in depth with these right now because we're going to talk about it more later. The exponential one is my absolute favorite one, though. It has a horizontal asymptote and it goes like this. And I just always do this motion when I talk about it. I call it a swoop. Okay, so it's going to have a horizontal asymptote and then do something like this. And the logarithmic is going to have a vertical asymptote. And then it's going to do something like this. So it's a sideways swoop. And I think all of those you would have, maybe besides greatest integer, you would have at least seen last year. These two are new, they're sine and cosine. The shape for both of them is a wave. Has anyone taken physics and like, have you seen the sound waves? You know what I'm talking about? It is that, okay? Here's how you tell, and their names are sine and cosine. But you took geometry, so you remember that sort of, right? We're going to do that later on in the year. Here's how you tell the difference between them, because they're both waves. You just look at where it starts. Sine starts at 0 and then starts to wave. So it goes up to 1, back to 0, down to -1, and then it would go back to 0. So you can kind of just like keep that pattern going. It's going to do that. So it starts at the origin. So sine starts at the origin and then starts to wave. But just look at this point. That's really the part that you need to remember. Cosine starts at 1 and then does its wave. So if you just remember where they start, then you can tell the difference. So cosine starts at 1 and then starts to wave. Other than that, they do look like basically the same. So just look for that starting point. This one's 0 and this one's 1. We basically just did the whole year, like, well, the first half of the year, all the functions. We're just going to go more in depth with all of those, but those are all the parent functions. Other topic we're going to look at today, just real quick, is slope, your equations of lines. And then the rest of the time will be yours. So let's review our formulas real quick. I know I'm asking you to remember back to algebra 1. Maybe I won't ask you. You're probably sick of being asked questions at the end of the day. Do you want me to just tell you? That makes me feel like I'm lecturing, but do you remember what letter stands for slope? I'll just ask you that. M, because that makes sense. All right. So your slope is y2 minus y1 over x2 minus x1. Sort of ring a bell? Like, okay, head's nodding. I'll take it. Point slope form. It is y minus y1 equals your slope, and then x minus x1. That's one that gets everybody, but it's actually the easiest one. You take y minus whatever the y number is, equals slope, x minus whatever the x number is. And then this is everybody's favorite. I don't particularly like this one as much, but do you remember slope intercept? Good. We knew that was going to get thrown in there. Good old y equals mx plus b. The reason I don't like that one as much, b is the y-intercept, and that's a really picky point. What if your y-intercept isn't pleasant? Like, what if it's 11/5? Do you know what I'm saying? Like, then this is not a good, like this, you can use any point you want. So, nice to that. We don't have to do all of these. I'm just going to pick like a couple. Let's just at least do the first one, and then maybe I'll do like one of the ones down here. All right, so slope. You're going to subtract the y numbers. The y numbers are the 7 and the -2. Are you with me there? So it's 7 minus -2. Hey, Ms. Cole, what if I want to subtract them the other way? You do you. Just make sure you're consistent with the denominator. So we subtracted our y values. And then these are the x numbers. You're going to subtract those. So -1 minus 2. I get that that's a lot of negatives. Let's talk our way through it. Minus a negative is going to cancel out. So what do we actually have up here? 9, good, over -3, beautiful. Oh, and that'll actually reduce further, just -3, or -3 over 1. Some people like to leave the 1 in there, and that's totally valid. All right, but your slope is -3. Already you should know, hey, when we graph this, the line should be going down. Why? Because it's negative. Okay, so point slope form. Here's your slope. It does not matter which point you use, so I always use the first one. For no other reason then, it's the first one. You have to pick one and go with it. All right, so here's your point slope. Y minus, for the point I picked, what's the Y number? For the one I circled, what's our Y number? Good. Y minus -2. Minus -2, that would be +2. Equals your slope. Hey, what did we find was the slope? We already found that, it's -3. And then in parentheses, x minus the x number, which look at your point, what was your x number? 2. That's it, that's the answer. You don't have to do anything else. I love point slope, it's great. Slope intercept's the annoying one because now you have to do work. Although it's only 2 steps of work, so it's not that bad. You're gonna distribute this. So it'll be y plus 2 equals what? You distribute that, what are you gonna get? Good, -3x plus 6. And then to get the y by itself, you're gonna subtract over the 2. So it'll be y equals -3x plus 4. And then we're just gonna graph that. So you would start it where? When you go to graph this, if you're looking at this equation, where would you start? Yep, start at 4, or you could think of it as up 4. And then your slope is -3, so you're gonna go down 3 over 1. (18) and 19 are the same exact kind of thing. You get your slope, write your equation, rearrange it. Let's do 20. I gave 20 backwards. You have the graph instead. So when you look at this graph, what would be the slope? Well, like look at 2 of the points that I bolded. How much up and how much over are you going? You're just going to count the little boxes. So what is it? Up 2 over 5, so 2/5. Like you're just counting is all that is. And then your y-intercept is -3, specifically 0, -3, but I would take -3. And so then your slope intercept is y equals 2/5 x minus 3. You're just putting that all together. And then these last 2 are basically like, are you a good noticer? When you look at these points, what do you notice about them? Like, because you can save yourself a lot of work if you notice some things. Yeah, do you see how these are both -3? Is that the x or the y? That's the y. So your equation is y equals -3. Like, Ms. Cole, that's the answer. Yep. I told you could save yourself a lot of work if you just notice that. It's going to be a flat line at -3. Ooh, what's that called? We played hangman with it. Good, well remembered. And what's the slope? Don't overthink it. Oh, I heard somebody say what the next one's gonna be. Slope of this is 0. What do you notice about these 2 points? I did a compare and contrast. We're gonna do the other one. It's the other way around. So which value is the 4, the x or the y? X. So it's x equals 4. Instead of horizontal, it's going to be vertical at 4. And what is that slope? It's undefined. Did your teacher teach it to you, Hoy Vux, that acronym? I know it's not a word, but neither is PEMDAS. It's just an acronym to help you remember. Horizontal lines have 0 slope and they are y equals. Do you remember what this is? Vertical, undefined, x equals, x values. Okay, so you can save yourself a lot of work if you notice that stuff.